analysis. So now we start the analysis. The first thing I'd like to mention before we consider the analysis is you need to prepare any categorical independent variables that have more than 2 categories for the regression model. Specifically, you need to dummy code each category within that categorical variable. For example, we have the variable education. Education is an independent variable with 3 categories. Right? So it's one variable, and it says, is your highest level of education high school? Is it college? Or is it graduate school? Right? One variable, 3 answers. Now, if we dummy code it for the regression model, what we do is change it so this one variable becomes 3 variables. Right? So to dummy code the category, that means variable number 1 is high school, yes, no. Variable number 2 becomes college, yes, no. And variable number 3 becomes graduate school, yes, no. And when we do the analysis, we need to specify one group, one category here, as the reference group. So if our dependent variable is happiness, we leave one group out, and the 2 that are left in the model, their level of happiness is judged in reference to the group left out. Right? So that'll be a lot clearer when we actually do the analysis. But this can be frustrating because if you're doing linear regression and you have a categorical variable with more than 2 categories, you don't know about dummy coding, then you're frustrated because you don't know how to treat the variable. So this is how to treat it. Right, so to do the regression in SPSS, right, so we have our path here, analyze regression linear for our dependent variable, the dependent box, the independence, and the independent. Remember to click collinearity statistics and OK. Right, so let's do that. So analyze regression linear, right? And we have all our stuff in there from before, but instead of plots, right, remember, for plots we click this. We don't want plots now. So you might want to put that back over there. Click continue. But under statistics, we click that, and we click collinearity diagnostics, continue, and OK. Right, pretty simple. Then it runs a regression, right? We get our findings, we get our collinearity statistics, and all the good stuff. So you'll see this is actually on the slide. So let's go back to the slide. So there we go. And we have our printout, right? So the first thing we want to do is pick up with our check for collinearity diagnostics, right? So at the very end of in the printout, at the very end of this table, we see the tolerance and VIF, right? And we see the VIF, nothing is below 10. I mean, for the tolerance, nothing is below 0.10. And for the VIF, nothing is greater than 10. And so that's a good sign. So we could say that the collinearity does not present a problem in this regression model. Now, in the printout, the very first thing that pops up are these 2 boxes. There's 4 boxes. These pop up. So we have the model, and then the second box says ANOVA. Now, the great thing about this is you'll see highlighted, right? The first thing we look at is the SIG, which reflects the overall statistical significance of the regression model. So we can have significant predictors, but that wouldn't matter if the whole model is not statistically significant. So the first thing to look at is in the ANOVA box on the far right-hand side. Is the significance, is the model significant? And for us, right, 0.05 means significant. It's way below that. So the model is statistically significant. So that being said, we can move to the next step. Obviously, if it wasn't significant, we don't need to look at any more of the model. So the next box we have are the individual predictors, right? So we're looking at how the individual predictors relate to happiness, the dependent variable. So the first thing we want to look at is statistical significance. Right? So which predictors are statistically significant? So the first one, many bills monthly, right? It's just over that 0.05 cutoff point for statistical significance, right? So many bills monthly is not significantly related to happiness. But we could see the next 4 variables say that these are all significant predictors of levels of happiness, right? So those variables are significant. So then next, we want to look at the directionality of these significant variables, right? So we dummy coded our education, right? So we know that these scores for the college and graduate school categories are in reference to the group left out, which is high school, right? So we know with this unstandardized coefficient beta, if there's a minus sign, the variable is negatively associated to happiness, as in when that variable goes up, happiness goes down. And so we see for the college and graduate school, both betas are positive and both are significant. So what it's saying is that in reference to high school, the group left out, in reference to high school, those with a college level education have significantly more, right, positive, more, a higher level of happiness. And then with the graduate school, what it's saying is in reference to those with the high school level education, those with the graduate school level education have significantly more, a significantly higher level of happiness. Pardon me. Now, if it was a minus sign, it would have meant significantly less than the reference group, but they're both significantly more. Now we see with the next independent variable, aloofness, the beta is negative, right? So it's negative 0.500, meaning as aloofness goes up, happiness goes down, right? So it's a negative relationship. And then for humor, pardon me, it's a positive 0.485, meaning as humor goes up, happiness, the dependent variable, also goes up. Right? So that's the directionality. So they're significantly related to the outcome, right, the dependent variable, but they could be significantly related in a negative or positive way. So that's what we've identified here. Now next, I just want to review what exactly the unstandardized coefficient indicates. And what it indicates is the level of change in the dependent variable according to the level of change in the independent variable. So this might look familiar, the regression model, y equals a plus bx. And so in that, y is the dependent variable, right? The next line you could see the y has been replaced with humor. The a is the intersect, so you don't have to worry about that. The intercept, and then so the b is the independent variable, humor, per se, and then we know humor goes 1 to 100. So in the parentheses is the x, which is the change, the level of change in the dependent variable according to the change in the independent variable. So what it's saying is for every 1 point change in humor, right, happiness goes up 0.485. So if it goes up 2, it's, 2 times 0.485, and then that goes through that equal, and then happiness goes up that much. So to put it simply, that the unstandardized coefficient beta just tells you how much change there is in the dependent variable related to the change in the independent variable. That's the take-home message. Now, you also might wonder, what's the strongest predictor of happiness, right? So we have a group of variables. We're looking at their joint effect on happiness, and we might say, well, which one has the biggest impact on happiness? You could look at the standardized coefficient beta, and that will indicate that message. So the highest standardized coefficient beta reflects the variable that has the strongest relationship in the model to happiness. And we can see here, for us, it's humor, right? The highest one is the last one, which is humor, which is 0.502. So we might say that humor in this model is the strongest predictor of happiness. Now, the R squared is a very important value, because that indicates the amount of variance in the dependent variable, right? For us, the amount of variance in happiness scores, which means what makes happiness scores go up and down, the percentage explained by the independent variables in our model. So you can imagine the value of that just every day. So if I told you that I could explain what makes you happy or unhappy, 50% of what makes you unhappy or happy in a day, you'd be pretty interested, right? So, well, that would give me a good deal of control over the happiness. So that's what we're looking at here, is what percentage, right? How much of the variance of the scores going up and down are explained by the independent variables. Now this is 0.887, which is like 89% of the variance in happiness is explained by our independent variables, which is exceedingly high. Usually it's 0.15, 0.20. When it starts getting to about 0.40, 0.50, then that gets to be, very high. So 0.89 is just unbelievable, but that's because, this is a kind of data I created. So it tells you the amount of variance in the outcome, such as happiness, explained by the group of independent variables. So it's a very important metric. So what would we say? How could we put it? We might say the multivariate model indicated that the independent variable humor was the strongest predictor, right, the standardized beta, of levels of happiness. Right? So that might be our take-home message for all that work, checking assumptions, right, all that stuff. Now, the interaction effects, possibly even more interesting than the linear regression, right? So what do we need to do to test for interaction effects? Well, I'm glad I asked, right? So the first thing we need to do is create an interaction term, right? Then we rerun the model with the interaction term in the model. And we see if the interaction term is significant, statistically significant, right? And if it is, we need to display the relationship, right? To model the relationship if the term is significant. I've seen a lot of papers where they'll test the interaction effect and it'll be significant, and they don't model the relationship. So if it's significant, it could mean a few different things, and if you don't model the relationship, you don't know which thing it means. So it's incomplete and inconclusive. So we don't want that, right? Okay. So to create an interaction term, So there's a few functions in SPSS you use all the time. The transform is one of them. So we're going to go to transform, compute variable, put a name in for the target variable. Under the numeric expression, we're going to put the independent variable by the moderating variable. Okay, many bills by humor, and click OK. All right, so let's do that. So go to our SPSS, go to transform, compute variable. There we go. I want to click reset. Right, so compute variable. Then we want to find, right, so it's many bills monthly, right there, by humor, right? That's our interaction term. Our moderator, an independent variable, and we might just call it, right, many bills, right, humor. And that could be reversed either way, it's fine. And then you just click OK. And then you'll see, right there, many bills by, there's our interaction term. Go back to our slides. There we go. So we did that. So we go back, like I said, we go back to our regression model, right? Dependent variable still there. The independent variables are still there. We're just going to enter many bills by humor. So we go back to analyze, regression, and linear. And so we want to stretch that out there. Sometimes it's convenient to put them right next to each other, like that. So, so the moderator and independent at the end. And then you just put in, there you go, the interaction term. Then you click OK. And you have the frame, which are, so there we go. And then you'll see many bills, humor, its significance, 0.012, so it's statistically significant. So let's see that on the slide. So there we go. So the first thing we want to look at is the term statistically significant. And as we saw before, and we see here, well, yes, it is statistically significant. Right? So we're going to look at that relationship. Now, one thing I'd like to mention, and this is worth the entire price of the webinar, in my opinion, is once you put that interaction term here, right? So now you have that same model with that interaction term. The actual independent variables, humor and mini bills monthly, are no longer independent variables with direct effects on the dependent variable. And this is probably one of the biggest common misconceptions in statistics is when people put this in, they look at the significance levels, and they say even with the interaction term, humor is still significantly related to happiness. And mini bills monthly, look, is now significantly related to happiness, right, as if they were direct effects. Right? But that's not true. Once this interaction term is entered in the model, these are what's called simple effects. So this variable, humor, and many bills monthly, these results refer to the cross-tabulation within here. So those are simple effects which now refer to the interaction term. Most people think that there's still direct effects that refer to their relationship with the dependent variable. So just knowing that puts you at a level of sophistication beyond like 95% of people reading studies. So you'll know that in this model, this no longer says humor is significantly positively related to happiness, right? You won't say that. You'll say that These are now simple effects, and you can't see the relationship between humor and happiness and many bills monthly and happiness in this model anymore, because these have changed into simple effects instead of direct effects. So I think I've really beat that into the ground, but that's really important. It's really important, that people kind of spread that message so people stop misinterpreting these findings. So now what do we need to do? Now we need to display the scores of the dependent variable, which is happiness, by categories of the independent variable and moderating variable. Right? So what does that mean, right? We're going to find out. So if the independent variable and or moderating variable is continuous, we must make high and low categories of that variable, right? Because we need to break these down into categories. So how can you take a continuous variable, such as humor on a level of 1 to 100, and change that continuous variable into a categorical variable that we can use to examine the relationship of the interaction term? Well, let's start here. If you recall, early on, we said that we wanted that the interaction effect would break down first to the left here. We have low humor and we have high humor, right? And then within these categories, we're breaking down people that have many bills monthly and don't, and have many bills monthly and don't, and then looking at the happiness scores. So how do you come up with this low humor and high humor categories so we can examine this interaction effect, right? Aha, it's the old bell curve coming back again, right? So here is the conceptualization of how we're doing this. Look at the peak in the middle. This 68% of scores, right? That's 2/3 of the population. Now, if I was talking about humor, right, people that, there's an average level of humor way at the peak there. It's the average, it's the highest where the most people are. Right over here, what's that person's level of humor? It's, a little high. And then to the left, what's that person's level of humor, right? So the people that are kind of crowded up to that top, their levels of humor aren't really that different. If they're a little to the right of the peak and a little to the left of the peak, right? It's not really that different. Their levels of humor are similar. However, if you travel down the sides, you see these tails, right? On the left side and the right side, there are these tails. And in the left one, those are significantly low scores of humor, right? So if we say that 2/3 of the population is in one standard deviation, that means that other third, those are the extreme scores. So if we look at roughly 15%, the 15% of scores to the left, outside one standard deviation to the left, those are the significant, extremely low humor scores. Then if we look at the scores, one standard deviation to the right, we could say, why, those are the extremely high humor scores, right? So we're eliminating that middle group that is kind of alike one another, no matter which side of the bell curve they're on, and we're taking the extremely high and extremely low group, and we're going to use them to make categories out of humor. Right? This is actually a great way to examine an interaction effect. So if people see you doing it this way, they'll say, wow, a great way to look at this interaction effect. Right? Okay. So how are we going to do that? Okay, so the first thing we need to do is determine what the actual mean and standard deviation of humor is, so we can figure out which scores are above and below one standard deviation, right? That makes sense. So we have analyze and frequencies. I'm going to select humor. And under statistics, we're going to click mean, standard deviation, continue, and then OK. This really isn't that bad. So we go to the SPSS, happiness database. Right? We go to analyze, descriptive statistics and frequencies. Get rid of age, and we're going to put in humor. Under statistics, we declick or unclick skewness or kurtosis. We click mean, and then down here we click standard deviation, continue, and OK. And there is our mean for humor, right? 63.04, and the standard deviation is 20.24. If we go back to our slides, by a stroke of luck, it's right here. So we have our mean and our standard deviation, right? So the low humor scores, right? So 42.8, we minus one standard deviation, so it's minus 20.24, which is 42.8. And then one standard deviation above is the mean, 63.04, plus standard deviation, 20.24, which is 83.28. So low humor is going to be 42.8 and below, and high humor, 83.28 and above. And so now we have to transform the variable humor. I know it just never ends, does it? So now we have to transform the variable humor into those two categories, right? So as I said, transform, you use it all the time. We used it already. We're going to use it again, right? So we're going to transform, and then we're going to recode into a different variable. So we're going to take humor, and we're going to give it a new output variable name. We're going to click old and new values. Now here's the important part. The range, we're going to make 0 to 42.8, right? So that means anything lower than 42.8. We're going to make that low, which is going to be coded as 0, and add. And then, now remember, the humor scale goes up to 100. So anything higher than 83.28, in other words, 83.28 to 100, right, that we're going to put the new value of 1 in, right, and then click add, and that's going to be high humor. And so then we're going to click OK. So let's take care of that. So transform, recode into different variables. Then we take humor and put it over there. And then we go under output variable name, and we might call it humor high-low because we're making high and low categories of this continuous variable. Click change. There you go. Now you go into old and new values. There we go. Now, remember we said we're going to do the range, so not the value, but the range. So the first one is, if you recall, 0 to 42.8. Right? And we're going to code that as 0. And click add. So that's saying 0 to 42.8 is 0, and 0 is, for us, is going to mean low, categorically low humor. Then we have, what was the 83.28. You can never be too careful. 83.28 to 100. Well, you probably can be too careful, but that's not that. This is just the right amount of carefulness, right? So the 1 is going to be high humor. So now we have two categories, 0 low humor, 1 high humor. We click continue, right, and then OK. And then you can look, and we have humor high, low, right? And the ones without the scores, those are the ones in the middle, right? back into here. So that then we have, so now what we need to do is we need to compute the mean score of happiness for each of those 4 categories we said would be included in our examination of interaction effects, right? Remember, high humor, low humor, then the 2 many bills monthly groups within each, right? So we have to select those groups. Then once we select those groups, we're going to run a frequency for the dependent variable happiness. So then we'll know what the score is for levels of happiness within each of those groups. Okay? So let's do that, and it'll be much more apparent. Okay, so the first one, let's call it category 1. Right? So let's say we're going to look at that low humor group first. So category 1, humor is low, and many bills monthly is going to be no, right? So no humor, but no many bills either. So let's see what their score is. Now you can see our path here is we're going to go to data, select cases, if conditions satisfied, and if. This is another one of those SPSS functions that you use all the time, right? And then when we get into if, we're going to select, right, humor low, high, right? So we're going to select equals 0, meaning low. Excuse me. And then many bills monthly, 1 is coded as yes, and 0 is coded as no, which should always be the case when you're coding yes and no, generally. Always generally. So maybe you should just say generally. So then we're going to continue and OK. We're going to do this for each of the groups. So let's go to data, right, and then select cases, right? Remember I said that? And then if conditions satisfied, I said that too. And then if. And then we are in the place to be. Then, excuse me, we select humor, high, low. Put that on over there. Equals what? Low. But low isn't LOW anymore. It's 0. So now we've selected low. Then we click the and, right, because we have another specification. And many bills monthly equals what? No. And no is not an O. It's now a 0, right? So now we're selecting humor, high, low, low, so, and many bills monthly, no. Then we click continue, and we click OK. Then we need to find that mean value for that category, the mean value of the dependent variable. So analyze, descriptive statistics or frequencies, right? So we got the mean, but we don't want the mean of humor anymore. We want the mean of the dependent variable, which is happiness, 1 to 100. Put that in there and click OK. So then we got that mean, which is, as you can see, 60. So go back to our slides. Now here's what's cool. So then we can start entering that mean score for each of these categories in our figure, right? So we have low humor, and then the arm here goes to many bills monthly, no. So low, many bills monthly, no. Hey, what's their score of happiness? It's 60. Okay. Well, let's see what everyone else's score is then, right? So as I said, got to do it for category 2, right? Which is humor low, many bills monthly, yes, right? And then same thing, data, select cases, conditions satisfied, and if. Then we're going to select humor low, high. We're going to select, still keep it low, 0, but then many bills monthly is 1. So let's do that. This would be redundant if it wasn't so repetitive, right? So here we go. So the good thing is it's all set up. We just need to go in here and change what? The humor high-low stays low, but the many bills monthly now is yes, and a yes is a 1. Continue, and OK. Then once again, we want the mean score for that group. Frequencies, and OK. The mean is 31.9, much lower than 60. So take a look at that. All right, so then we want to what? Enter it. So there we go. We have now filled in half the chart for the interaction term, right? So we know there's significant differences. So now we're plotting, right? So we have, for low humor, the 2 happiness scores. Those with many bills monthly, and those for without many bills monthly. And we see already a difference for those in the presence of low humor. So when people have low humor and they have many bills, they have half the score of happiness than those with low humor who don't have many bills. Quite interesting, right? It could almost be called cool. All right. So what do we want to do next? Well, you can guess, right? I'll keep it on there. You can guess. Category 3, right? So we're switching to humor high, and then many bills monthly, yes, right? So same thing, right? We're just going in there and changing the numbers. So now humor low high is going to be 1 high, and many bills monthly is going to be 1 yes. Right? Same thing, just a couple of switch of the numbers. So data, select cases, if conditions satisfied, if, and we're going to change humor high-low to 1. So that's high humor, and many bills monthly, yes. We're going to leave that. Sometimes it's good to write down what you're doing because, you could forget which 1s and 0s you looked at. Then descriptive statistics frequencies, and OK. 73, very interesting, right? So a mean of 73 for that group. So we go back, go down, we enter 73. So high humor, many bills monthly, yes, 73, right? So look at that. Even if you have many bills, if you have humor, you're still higher than the other 2 groups with low humor. Now, remember what we said earlier, that we thought the group that's going to have the highest level of happiness are those without many bills monthly. Many bills monthly, no, and high humor. So that's the group we're about to look at to see if we were right. And so category 4, the last one, right? Humor high, many bills monthly, no. Right, so 1, data select cases if conditions satisfied, if. Now, 2, humor low high, it's going to be high. And many bills monthly, 0, no. Continue, OK. And then we do our mean. So let's look at that. Data, select cases, yes. So humor high low, 1. Yes, leaving it at that. Many bills monthly, 1. No, we're going to make that no. So these are the people we think are going to be the happiest or have the highest happiness score. Then we say analyze, frequencies. You have to say that when you're a scientist. 78.0. That is the highest, right? So 78.0, and we enter that in there. So now you have these 4 groups. And there's a point I want to get across here. When you look at these scores, it could be a little inconclusive and dizzying. You could say, well, the people with high humor both seem pretty happy, And the people with low humor, the people without bills seem happy. It just seems like that people with low humor and bills, they just seem unhappy. So what's the take-home message? That if you have low humor and bills, you're probably the least happy. But that's covering up the real effect, right? So to really display the relationship you're looking at, sometimes it's a great help to graph the relationship. Look at that, right? So here's the graph to help with the interpretation of the relationships we're examining. So you can see the blue line with the squares is our group for many bills monthly, no. The people that don't have many bills monthly. And the red line with the triangle are the people that do have many bills monthly. You'll notice that I've listed moderating variable under there because it's the moderating variable, right? Because you could say, well, maybe couldn't we make low and high humor, like the lines with the squares and the triangles? Well, you could, but really that should be the moderating variable. So the moderating variable should be the variable with the slopes that are measured, from one point to the other. And you'll see down at the bottom, independent variable, right? So that's where our independent variable made into categories is displayed, right? So we have the independent variable, low humor to high humor, right? Right there. So we can see for many bills monthly, know what happens to their levels of happiness going from low humor to high humor. And we get the same thing with many bills monthly, yes, right? So really what we stated before was covering up the real effect. The real effect seems to suggest that in the presence of high humor, right, those with many bills monthly and those that don't have many bills monthly, their level of happiness is really kind of similar, right? But in the presence of low humor, right, it seems like that people that do have many bills monthly have a significantly lower mean score of happiness. So stated scientifically, you might say in the interpretation of the interaction, in the presence of low humor, those with many bills monthly have significantly lower happiness relative to those without many bills monthly. However, in the presence of high humor, those with many bills monthly had similar happiness scores relative to those without many bills monthly. So the data suggests that having high levels of humor may be protective of one's happiness in the face of having significant economic demands, i.e. many bills monthly. You often hear protective in the interpretation. So two things you hear in the interpretation of interaction. In the presence of, right? The presence of low humor, in the presence of high humor, and you often hear protective. Something's protective of, because it's referring to that change from one side to the other. Right? So in conclusion, our first model examined the direct effects between the independent variables and the dependent variable, which was continuous, which is appropriate for linear regression. Right? Then we looked at indirect effects. Right? So the interaction effects, those are indirect effects. Right? We looked at those. Now another big indirect effect is mediation, which is cut off by the logo here, but mediation is the other big indirect effect that people like to examine. So that should be probably the next on your agenda of learnings is after the interaction effects is to consider those mediation effects. And then you'll have a very nice repertoire of being able to identify and express indirect effects. So I'd like to thank you for attending the webinar, and I will be in touch.